Well, this is least squares regression, and this first set of steps here is finding a linear equation that relates x and y values together based on 2 points. This is algebra based. Step 1, pick two data points, first and last maybe. These will be x1, y1, and x2, y2. Step 2, find m using the formula. M is equal to y2 minus y1 over x2 minus x1. Into y equals mx plus b, plug in either point for x, y, and m from step 2 and solve for b. And then write your answer. Plug in m from step 2 and b from step 3 into y equals mx plus b. Let's take a look at this first problem. Get my pen to work here. There it goes. Okay, so we got x and y. 1, 2, 3, 4, 5, 13, 20, 35, 41, and 40. And first thing it says, create a scatter diagram, pick two good points, and find the equation line between them. I'll just do this by hand. Okay, so I got 1, 2, 3, 4, and 5. Our largest value is 40, looks like. 40, halfway up would be 20, and then halfway up to 20 would be 10, and then halfway between 20 and 40 would be 30. Our first point is 1, 13. Be right there. 2, 20. 3, 35. 4, 41. And 5, 40. Okay. Now it says pick two good points and find the equation line containing them. If I pick this one here, kind of draw a line through them, then that one really wouldn't be a good. That seems kind of the oddball. This first four kind of follow a pattern. Now, probably ones to pick, maybe the first 2 points. Those look like it'd be a pretty good line going through there. So I'll use this one, and I'll use this one. So these would be the points 1, 13, and 2, 20. And they say find the equation line containing them. Okay, well these are the steps we just looked at here. Pick two data points, first and last maybe. The last would have been a bad one in this case because it looks like kind of like an outlier. It says find m using this formula. Well, this is my first point, so this would be x1, y1, and this would be x2, y2. This is step 2. Find m using this formula. We got y2 minus y1 over x2 minus x1. Again, it's a good idea to go through and put parentheses wherever you have variables first. Now y2 we said was 20, y1 is 13, x2 is 2, and x1 is 1. 20 minus 13 is 7, 2 minus 1 is 1. So we get m is equal to 7. Step 3, into y equals mx plus b. Plug in either point for x and y. It doesn't matter which one you pick. I'll pick this first point, so I'll plug that in for x, plug that in for y. So I got 13 there. And it also says plug in m from step 2. M we just said was 7. So put 7 there, put the x here, plus b. Now if I take the 7 over, it becomes negative 7. And we get b is equal to 6. Then it says write your answer, plug in m from step 2 and b from step 3 into this formula. Well, from step 2 we said m was 7. So we've got y is equal to 7x and b is 6. So that would be our equation in the line. Now if I were to draw that, y is equal to 7x plus 6. It's not asking you to do this, but this is extra. The 6 is our y-intercept. So that'd be right here. The 7 is our slope, and if I put it in fraction form, it'd be 7 over 1. That says I go up 7 and right 1. Up 7, right 1 would be right here. And then if I draw a line through them, it actually should pass through those 2 points. I'd get that line right there. And you see, this isn't too bad of an estimate for this. We have some error. See how these aren't right close to it? The idea in this section is we're going to try to find out the best line that goes through this with the least amount of error. Okay. Now some definitions. The residual. This is the difference between the observed and predicted values of y, aka the error. Formula is residual is equal to observed y minus predicted y. Now the observed y would actually be our points here. The predicted would be this red line. So that's what we're predicting it's going to be, but the actual data points are right here. Now observed y minus predicted y. Well, if I take this right here and I subtract off this is the distance between them. Observed minus predicted. This may give me like 3 or 4 or something. Maybe that'd be 4. But over here, if I subtracted these, this is the observed minus predicted. Observed minus predicted, I'd get like a negative. And this might be -5. So our residuals are kind of dependent upon where the point's at. Is it above or below the predicted line? Okay. Now least squares regression criteria says the least squares regression line is a line that minimizes the sum of the squared errors or residuals. This line minimizes the sum of the squared vertical distance between the observed values of y and those predicted by the line y hat, red y hat. We represent this as minimize sigma residuals squared. So minimize the sum of the residual squared. Now, these are the formulas we're going to use for finding least squares regression line by hand. And let's do this first. I'm going to do this one by hand. So let's start in with this example. Now I'm going to save that. And what is this? Least squares regression. So let me save this page, and then we'll start a new one. So least squares regression page 01.pdf. There we go. And this problem is number 2. One, 2, 8, 13, and 10, 15, 35, and 44. And we're going to want to use these formulas to find our least squares regression line. Okay. So it's y hat is equal to b1x plus b naught, and we need to find b1, b naught. Within that, we're going to have x bar, y bar, sx, sy, and specifically r. So let's go through here first. And our first step is going to be to find x bar. Well, x bar is our mean, and we're going to add together all the x values and divide by how many we have. There's 4 of them. So that's 10, 23, 24. 24 divided by 4 is 6. We're also going to need, step 2, find y bar. Y bar, we'll add together our x values. So we've got 10 plus 15 plus 35 plus 44 divided by 4. Let's see, 15 plus 35 is 50, 94, 104 over 4. This is x bar. And, 24, 26. So y bar is 26. Our third step. We're going to need to find s sub x. Well, this is, let's see, I have my x values here. Let me scroll up. That's 1, 2, 8, and 13. So 1, 2, 8, and 13. And, let's see, this would be x minus x bar. And x bar was 6, so we got 1 minus 6 equals negative 5. 2 minus 6 is negative 4. 8 minus 6 is 2. 13 minus 6 is 7. And we'll have x minus x bar squared. So we'll have negative 5 squared, which is 25. And we'll have negative 4 squared, which is 16. 2 squared, which is 4. And 7 squared, which is 49. Now, we're going to need to add those together, and that'll give us a sum of x minus x bar squared. Let's see. It's 10, 19, 4, 2, 4, 5, 94. Let me get my calculator out. I want to check this. 25 plus 16 plus 4 plus 49. 94. Okay. Now s sub x is going to equal to the square root of the sum of x minus x bar squared over n minus 1. So we'll have 94 up on top here, and we got 4 numbers, so that's 4 minus 1, which gives us 94 over 3. And square root of 94 divided by 3 gives us, I'm going to take this to 5 decimal places, 5.59761. 62, sorry. There we go. Well, step 4. We need to find s sub y. So I'm going to have y values, and let's scroll up, see what those are. 10, 15, 35, and 44. And we'll have y minus y bar, so we got 10 minus 26, which gives us negative 16. We have 15 minus 26, which gives us negative 11. 35 minus 26, which gives us 9. And 44 minus 26, which gives us 18. Then we're going to have y minus y bar squared. So I'll have negative 16 squared, negative 11 squared, which is 121, 9 squared, which is 81, and 18 squared. 16 squared is 256, 18 squared is 324. I want to add those together, and that'll give us our sum of y minus y bar squared. So 256 plus 121 plus 81 plus 324. And then we get 782. So then s sub y is going to equal to the sum of y minus y bar squared over n minus 1, which gives us 782 over 4 minus 1. 782 over 3. And 782 divided by 3. We get, I'll take it to 5 decimal places again. 16.14517. 14517. Okay. Getting closer. So now we have s sub y, f sub x, we have x bar, we have y bar. The only thing we don't have is r, so let's go ahead and finish getting that. So that, I think we're at step 5 now. Yeah, step 5. If you're real curious about these steps, these steps are over in the previous section. So we'll have our x values and our y values. And let's see, 1, 2, 8, 13. 1, 2, 8, 13. 1, 2, 8, 13. And our y values, 10, 15, 35, and 40 something. 44. And we got a new column that's going to be x minus x bar over s sub x times y minus y bar over s sub y. So we're going to have 1 minus x bar. I think that was 6, but let me go up here. 6 and 26. Okay, so this is 6 over s sub x, which is 5.59762, and y, which is 10, minus y bar, which is 26, divided by s sub y, which is 16.14517. And this one will be 2 minus 6 over 5.59762. And this will be 15 minus 26 over that. And this one will be 8 minus 6 over 5.59762. And this will be 35 minus 26 over 16.14517. And this one will be 13 minus 6 over 5.59762. And this will be 44 minus 26 over 16.14517. Okay, let me plug this in my calculator. So I got 1 minus 6 divided by 5.59762. Close parentheses on that. Beginning parentheses, 10 minus 26. Closing parentheses divided by 16.14517. 16.14517. Closing. Enter. Okay. First one to the 5 decimal places. 0.88521. The next one. I'm doing second enter, bring up the previous entry. Very handy in these problems. And this one will be 0.48686. And next one, it's 8. And this will be 35. And that's 19917. And last one. 13 minus 6, 44. And we get 1.39420. Okay, now we want to add those together. And I'll just put a sum here, but this is a sum of all that. So 0.88521 plus 0.48686 plus 0.19917 plus 1.39420. Assuming I added correctly, didn't type anything in wrong, be 2.96544. Okay, so R is going to equal to that sum that we just found divided by n minus 1. So the sum right here, which is the sum of these. So that'd be 2.96544 over 4 minus 1, because we've got 4 sets of points. Divided by 3. And the 4 decimal places would be, actually I'll take it to 5 just in case. 98848. Okay. So let me write down everything we found. X bar was 6, Y bar was 26, S sub X is equal to 5.59762, S sub Y is equal to 16.14517, and R is equal to 0.98848. Okay, so B1 equals R times S sub Y over S sub X. Well, R was 0.98848 times S sub Y, which was 16.14517, divided by S sub X, which is 5.59762. So let me type that in my calculator here. 0.98848 times 16.14517 divided by 5.59762. And I don't know how many decimal places. 2 maybe? I don't think I put that in instructions here. Yeah, I don't say how many. So let me take it to 2 decimal places. 2.85. And B naught. B naught would be Y bar minus B1 times X bar. Well, Y bar was 26 minus B1, which was 2.85, times X bar, which is 6. So I got 26 minus 2.85 times 6. Now I've taken some liberties here. I'll go ahead and mention them. You shouldn't round ever until the very end of your problem. Since I expect most of you will use a graphing calculator for this, I've kind of been sloppy about that. It's just I wanted to round it somewhere, so I chose 5 decimal places, except for the very last here. So now that tells us y hat is equal to b1 b1x plus b naught. So our least squares regression line, b1 will be 2.85, and b naught will be 8.9, assuming I did everything correctly. Well, let's do this on the calculator, which is where you should be doing it. Here's going to be our steps. Put your x values into L1, put your y values in L2. So let's do that first. Go over here, I'm going to exit out of that, the second mode. Clear, press stat, do enter on edit. I'll press delete a few times to clean out those numbers. Same thing here. And in our L1 we have 1, 2, so 1 enter, 2 enter, 8 enter, 13 enter. I'll right arrow over here, I'll put 10 enter, 15 enter, 35 enter, and 44 enter. And always you want to exit out after you get done inputting numbers. There we go. Now we're going to press our stat button. Then it tells us to right arrow to calc. And it tells us to choose linear regression. So I'm going to come down to the fourth one. Now this is assuming you've turned your diagnostics on. And then it tells us to just press our enter. And so it gives us A, which I rounded 2 decimal places would be 2.85. 2.85. And it gives us B, which if I rounded 2 decimal places would be 8.89. I guess when I rounded this earlier on, I kind of got that off a little bit. Like I said, you shouldn't round to the very end. But anyway, that gives that to us. Now, if you don't see these for some reason, again, you have to turn your diagnostics on. So if you do second 0 to go in your catalog, and then you do alpha D, which is x to negative 1 here, and then alpha D again, it'll go down to your D's real quick. Or you can just keep doing down arrow over and over. And you want to keep going down till you find diagnostics on. Now, once you have a little cursor next to diagnostics on, you just press enter twice. And then you go back and do your linear regression. If I press stat, right arrow to calc, enter on one of our stat, or let's try that again. Stat, right arrow to calc. I'm so used to doing one of our stats. And then I'll down arrow to the linear regression. And press enter on it, and then press enter again. And you should see all these values. And that's how you do it via the calculator. Okay. Now let's talk about how to use a regression equation for predictions. Well, first step is to find the regression equation y hat. And I only did that by hand one time. The rest of these I'm going to do on the calculator. Then plug in the x value that you're wanting to predict and simplify. So let's look at this problem. And let me save this off. And this is problem number 3. And they give us some x and y values. X is 3, 5, 7, 9. And y values are 17, 23, 41, and 50. And it says, use the following data and its corresponding regression equation. Predict y when x is equal to 21. So predict y when x is equal to 21. Well, first thing let's go back to our steps. First thing we have to do is find y hat. So we're going to plug this in our calculator. And come over here, I'll go into stat, enter on edit, and I'll delete to clear out these. And same thing here. And we've got 3, 5, 7, and 9 for x values. So 3 enter, 5 enter, 7 enter, 9 enter. Right arrow over. Got 17 enter, 23 enter, 41 enter, and 50 enter. Okay. You want to make sure you exit out, so do a second mode. Now to do our linear regression, I'll go into stat, right arrow to calc, and I'm going to choose the fourth one. So I'll go ahead and press 4 instead of down arrowing, and then press enter. Now it assumes L1 and L2, so if you're not putting them in L1 and L2, you need to. And it tells us A is 5.85. So we're going to plug that in for the A in the formula at top here. So that's 5.85x. And it tells us B is negative 2.35. So plug that in for the B up there. And that'd be negative 2.35. Now it wants us to predict Y when x is equal to 21. So now we're going to plug in 21 for the x into the prediction equation we just found. And let's see what I get. 5.85 times 21 minus 2.35. I get 120.5 when I plug it in my calculator. So that'd be our answer. That's our prediction of what the y value is going to be. Okay. Now we've already talked a little bit about residuals. This is the difference between the observed value of y and the predicted value of y, aka your error. How far off is the line you just found? Now our formula is residual equals observed minus predicted. Now residual is y minus y hat. Y is the actual data point, and y hat is your predicted. That's one you got off of linear regression off your calculator. And then your sum of the squared residuals is the sigma, the sum of y minus y hat squared. We'll come back to that. Let's first look at this problem. It says, based on least squares regression line below, find the residual at x equals 3 given the actual data point below. Okay, so the actual data point is 3, 9. Now we're going to be finding the residual. So let me come up here to a formula. And the residual is y minus y hat. So the y is going to be the y part of this. So y is 9. The other thing we need is y hat. Well, they tell us y hat here. That's our model. So 3.1x minus 0.05. And we're wondering at x is equal to 3, so what we're going to do is we're going to plug 3 in for our x. So y hat is going to equal to 3.1 times 3 minus 0.05. And again, the y hat is our prediction. 3.1 times 3 minus 0.05. And I get 9.25. So our residual is going to equal to y minus y hat, like that, and y we said was 9, minus y hat, which was 9.25. Now this is going to give us a negative 0.25, and that would be our answer. That would be the residual. Well, let's find the do the next problem. This is find the sum of the squared residuals. So let me write this down. We got x, which is 3, 5, 7, and 9. And we got y, which is 17, 23, 41, and 50. And find the sum of the squared residuals. Well, let me come back up here in my formula. Sum of the squared residuals. Let's look what we need. We need y. I got the y's. We need y hat. So let's go find y hat. And we'll do that via our calculator. So come over here, I'll press stat, enter on edit, press delete a few times. And the x values are 3, 5, 7, and 9. So 3 enter, 5 enter, 7 enter, 9 enter. 17 enter, 23 enter, 41 enter, and 50 enter. And we'll exit out, do a second mode. Okay, then we got to press stat, right arrow to calc, and choose linear regression. So I'll press 4, and then I'll press enter. Again, assumes L1 and L2. Looks like this is one we already found. A is 5.85, and B was negative 2.35. Like that. Okay. So now when it says find y hat, that says plug in your x value into here and see what it gives you. So we got 5.85 times 3 minus 2.35. We got 5.85, and this x value is 5, minus 2.35. Then 5.85 times 7 minus 2.35. And 5.85 times 9 minus 2.35. Let's see what we get. 5.85 times 3 minus 2.35 5.85 times 3 minus 2.35, I get 15.2. On the next one, I got 5.85 times 5, 26.9. Next one, 7. I'm doing a second enter to bring up my previous entry. It makes it so easy on TA3, TA4. And I'm just using my arrow keys to go over and change the one number. And we get 50.3. Okay. Well, this says y minus y hat. So we need a column for y minus y hat. So take this y value, which is 17, minus y hat, which was 15.2. Take 23 minus 26.9. 41 minus 38.6. And 50 minus 50.3. Some of these I'm sure are pretty easy. I'm sure that first one's 1.8, but I mess up on decimals real easy. So let me go ahead and plug it in. 1.8. And next one is 23 minus 26.9, negative 3.9. 41 minus 38.6, 2.4. And 50 minus 50.3. Then we get negative 0.3. Okay. Now this is y minus y hat squared. So we got y minus y hat now. So let's find y minus y hat squared. So this would be 1.8 squared. This would be negative 3.9 squared, 2.4 squared, and negative 0.3 squared. Now, usually the common error right here is people will square something to come up with a negative number. Whenever you square something, it's always positive. So you don't even need to worry about sign. You know it's going to be positive. And this one is 15.21, 2.4 squared, 5.76, and 0.3 squared. That'll give us 0.09. Now we want to add those together. That's the sum of the squared residuals. This is the residuals right here, in case you're wondering. So we add those together. We got 3.24 plus 15.21 plus 5.76 plus 0.09. 3.24 plus 15 plus 5.6 plus 0.09. That gives us 24.3. And this is the sum of the squared residuals, which is what they are wanting in this particular problem here. Now there is no way to do that by hand. You have to do that via, there's no way to do it via the calculator. You have to do that by hand. But again, I would find y hat using the calculator. It'll save you so much time. Usually from online students, when they hit 4.1 and 4.2, I usually get emails at that point saying, isn't there an easy way to do this? Because they're doing it by hand and they're spending huge amounts of time. Well, the easy way is to use the TA3, TA4. If somebody's put off buying one up to that point, they usually break down and buy it. Let me save that. And then I'll stop the video. As soon as my tablet gets done blowing up, there it goes. Okay. And F10.